This video is going to cover section 7.3, properties of triangles. We're going to go ahead and discuss how to find similarity, congruence, and a little bit of Pythagorean theorem as well. Okay, real basic stuff. Okay, so first of all, we have this definition here that similar figures, so just similar figures in general, have the same shape, they have the same corresponding angles. In other words, the corresponding angles are equal to each other, okay, but they can be different sizes. So you can have like a mini-me version of another figure, okay? They also have equal ratios for corresponding sides, and this is actually one of the bigger things we're going to be talking about, looking to find, okay? So here we have again a more definite definition of this, okay? For similar triangles, the ratio of corresponding sides are equal. The ratio of corresponding heights are equal to the ratio of corresponding sides. Measures of corresponding angles are equal. So same thing that I just mentioned. I went ahead and included a figure here to kind of show you how this works with triangles, okay? Because that's what this chapter is about, triangles. And you can see that we have corresponding angles. So, like for instance, angle A is congruent to angle D. So this angle is equal to this angle, okay? And we know that it's congruent because we have this symbol. So when you have this little like squiggly with an equal sign, that means congruence, okay? Whereas if you have just the squiggly, that means similar, okay? So the angles have to be congruent, okay? And you can see the same thing with the other ones. Angle B is a right angle, and angle E is also a right angle. Angle C is 40 degrees, and angle F is also 40 degrees. So we can see that all corresponding angles, the ones that match each other, are equal to each other, okay? Similarly, corresponding sides are not congruent, these are similar. So these ones are going to be similar, meaning they have the same ratio to each other, okay? And I'll talk about that in a bit. So in other words, AB, so this piece right here corresponds to DE, which means that if these two are in fact similar, this would match up with this one, okay? BC, so that means the bottom piece, this one right here, is similar to EF. Again, if these triangles were in fact similar, these would match up with each other. And AC, which is our last piece right here, also known as the hypotenuse, AC matches DF. So according to what it says up here, it says triangle ABC. So this triangle ABC, okay, is similar to triangle DEF. So DEF. So since we do have it notated up here, that means that all of these conditions are met. And because of that, we have this proportionality with the sides. That's what this piece is right here, okay? If this is in fact true, that means that AB, so this piece right here divided by this piece right here would be the same as dividing BC by EF. And you can do the same with the last remaining side. And this is important because this is what we actually use to find missing sides, okay? So with that in mind, here's an example. A lot of this is reviewed from geometry classes, so we're gonna just kind of go through examples that are already done for us. It says the two triangles at the right are similar triangles, so we know that they are similar. Okay, find the length of side EF. Round to the nearest tenth of a meter. So we're looking for side EF, which would be this piece right here. Okay, since we know that they're similar, that means that we can match up some of the sides. So EF matches up with this piece right here, CB or BC. Okay, they went ahead and did BC. So you can see that right here, EF over BC. Okay, and we're just going to call this one, well, we can leave it as EF. So this is EF. Okay, and we also know since they're similar, the other sides must match as well, which means that AB must match up with DE. Okay, since I went ahead and did EF, which is the bigger triangle, so I did the big triangle, so big triangle was on the top, then that means, so EF, that means that the small triangle measurements will be on the bottom. So when you are doing these problems, you have to keep that consistent, okay? So here's DE, okay, which is this piece, which is the 10, and AB would be the 6. So you can see that in this step right here. They already plugged it in. And they also plugged in BC because we know that BC is 4. And then from this point, you just cross multiply, okay, which would give us 10 times 4, which is this piece right here, and then 6 times EF, which is this piece right here. Multiply, so 4 times 10 is 40. And then at this point, this is kind of like an X. This right here is kind of like saying 6x is equal to 40. So we would divide by 6, and x is going to give you approximately 6.7, or EF, because that's what x represents. Okay? And yeah, that's pretty much it. So these ones, the biggest issue is just making sure you set them up correctly. This is a key thing here. Whatever you put on the top has to match whatever you put on the top for the other fraction. Okay, same with the denominator.